Hello everyone, welcome to wireless networking series. Guys, today in this video we are going to learn how a device client connects to an AP, to an access point. Guys, in previous video in last class we discussed many things about access point, like why we come up with access point, what is access point, functions of access point, like you can use one AP to extend network coverage. You can use access point to connect wireless networking devices to a wire network. You can use access point to distribute the load of network traffic, right? Then we talked how access point works. So access point can work in three mode: root mode, repeater mode, and breeze mode. So we seen the difference between each mode. Then we talked about some basic terms of wireless networking. After that we discussed real time requirement. So in real time client roaming should be there, right? Means a client should be able to move from one ap to another ap seamlessly, right? So there should be no disturbance while shifting a client from one ap to another ap. Or let's say a client is moving from first floor to second floor, and at each floor we have different ap. That means your client device is going to disconnected with ap number 1, and it will connect with ap number 2. So how a client machine can move from one ap to another ap smoothly, or you can say without any disturbance, that is known as client roaming. Then we talked about load balancing, bandwidth management, and guest access. After that we seen some basic configuration, basic uh, terms to set up a ap, like configuring ssid, security settings, and basic network parameter. Then we talked about the VLAN configuration, like in advanced configuration you need to create VLAN, you need to map SSID with VLAN. Then you can configure the quality of service, or you can enhance security features, right? Then site survey is required, guys, for setting up a wireless network. Then deployment, how you are going to deploy it, and after that what options you have for monitoring and maintenance. Then we discussed about ap modes, like standalone modes. ap modes means how you are going to configure the ap, right? The mode of access point means how the access point operates within a network, that is modes. So again we have multiple modes, guys, like a standalone mode. So in a standalone mode your ap works independently. See, first of all, my ap works on three mode, that is root mode, that can be repeater mode, and breeze mode. breeze mode Then, guys, we have again multiple modes, like standalone mode means how you are going to configure the ap, right? So let me give you some example in packet tracer. Here I have packet tracer software, and in this packet tracer software, let's suppose I have some wireless networking devices, guys: pcs, server, tablet, right? So I need to connect these devices together wirelessly. So I need an access point. So in the packet tracer you can find wireless devices. Under wireless devices you can have access point. Here, yes, you can see this is my access point. So I can use this access point 1, to connect these all end devices together wirelessly, right? So you can see the tablet machine is get connected with ap. In the same way, this pc can also get connected with access point, but remember the fourth class, or I think fifth class. Here you need wireless nic, wireless network interface card, right? So on the pc you need to add wireless interface card. So just turn off your pc, and then you can remove this card and please insert one wireless card. So it can be wmp 300n, and now let me turn it on. So now pc4 can also get connected with your ap. Yes, you can see in the same way pc5. So to connect pc5, again I need to remove this card and I need to insert wireless nic here, right? Then, guys, on server also I need to turn it off. Then I need to remove this card and I need to insert one wireless nic here. And now these devices are connected with your ap, right? Now you can configure the AP, means you can configure the SSID over here, you can configure the VLAN, you can configure security setting, right? And then you can connect your AP to switch. So let's suppose here I have one switch, that is switch number switch 1, and now I can connect my AP to this switch. So in this scenario my AP is working on root mode because I have configured the AP, I have set up the AP, and I am managing the AP. I am not using any controller, or my AP is the main AP who is connecting all wireless devices to wire network, right? So in this scenario, this AP is working as a main AP, right? So this AP is going to generate the signal, is going to transmit the signal radio from their radio interface, right? And now you can have one server that can be your authentication server. As I told you, authentication server is required to authenticate the users so that only authorized users can connect with AP. So this server is going to authenticate client before connected with AP, and then I can connect my switch to router and router to internet. Let's suppose this is my router, and now I can connect this router to internet, and now these all client machines can access internet with the help of AP, right? So AP over here you can see AP is connecting wireless devices to wire network. This is my wire network, right? So guys, in this scenario my AP is working on root mode. Now issue is this AP, just try to understand the concern. This AP can transmit signal in this area. Let's suppose this is the area where this AP can transmit the signal, right? Because AP will have, you know, capability to transmit signal in a certain area, maybe 300 feet, right? So this AP is transmitting signal in this coverage area, right? Soon we are going to discuss coverage area also, like area, multiple types of domains are there in wireless networking, we will discuss. Now I have one small area here, right, where I want to implement wireless network. Let's say here I have some wireless client, right? So these wireless clients are not able to connect with AP. The reason, AP is not transmitting signal in this area, right? This area is out of range, correct? So here I can add one new AP, right? And then I can connect this AP to switch, AP number 2. So again guys, in this scenario my both AP number 1 and AP number 2 is working on root mode. But just try to understand here, implementing cable is impossible. Here I cannot implement any cable, right? Just suppose this is outdoor environment where I need to extend the wireless network, right? And let's say for some time this is my temporary network, for 2 hours or for 5 hours only I want to provide network connectivity in this area also, right? And as implementing or running cable is impractical over here, impossible here, so how I can provide or how I can transmit wireless signal in this area? Yes, I can use a AP in repeater mode. I can install one AP over here, that is AP2, and I can configure this AP in repeater mode. Repeater mode means this AP is going to repeat the wireless signal. Whatever signal this AP will receive from AP number 1, whatever signal AP2 will receive from AP number 1, AP2 is going to repeat it in this area, right? Now in which area, on in all direction or in a specific direction or in a specific area where AP is going to transmit the signal, that depends on antenna, that which type of antenna you are using. It can be omnidirectional for all 360-degree, and it can be directional for a specific direction, or it can be for a specific area. So whenever I am using a AP to extend the coverage, or you can say to repeat the wireless signal, in that scenario you need to configure AP in repeater mode, right? So here you can see there is no any wire connectivity between AP1 and AP2 or between AP2 to switch. I have not connected switch 2 to AP2 through wired. AP2 is connected with AP number 1 wirelessly, right? Both devices are connected wirelessly, and now AP2 is transmitting the signal. So advantage is it is good to extend wireless network. Disadvantage can be bandwidth, right? Bandwidth is going to be reduced, guys, here. Okay, so repeater using an AP in repeater mode have their own advantage, have their own disadvantage. Okay, so let's suppose here also I have one access point, and again I have some, again I have some and devices here like mobile phone, tablets. These devices are there, right? So I can connect these devices to this AP, AP number 2, and then AP2 can retransmit the signal of AP1, right? So AP2 is not going to generate any signal over here. AP2 is just repeating the signal of AP1 only. Okay, so this AP is working on repeater mode, this AP is working on root mode. And then guys, third mode is your breeze mode, right? So breeze mode means, let's suppose I have two LAN network. I have one switch here and one switch here, right? This is different building, let's say building 1, building 2, right? In building 1 I have this network, in building 2 I have this network, right? Now I need to connect these two wire network together, or let's suppose these switches are connected with AP as well. That can be also scenario, right? Here you can have one AP as well. Here also you have one AP. Now you need to connect these two network together. Again you can use AP, right? If you want to connect these two network wirelessly together, two LAN or two private network together wirelessly, then guys I can use access point here, right? So now I can connect this access point to switch 1 and this access point to switch 2, and I can configure these two access point in breeze mode. I can connect these two access point in breeze mode, right? Breeze mode, so that both AP will get connected with each other wirelessly, and then these all client can communicate with each other in same network, right? All end users are member of same network. So even I can use access point to connect two different network together as well, right? And then guys, again we have multiple modes, like here you can see a standalone mode. A standalone means your AP is working independently, the AP operates independently. That means you have configured the AP, you have configured the SSID, you have configured the VLANs. So if you are managing the AP, that means your AP is working on a standalone mode. If you are using a controller, that means your AP is working on controller based mode, that is controller based mode. So here you can see I have one AP which is connected with end devices, right? And all end devices are able to access internet or network resources with the help of AP. So whenever you have few number of APs like 1 2 3, you can configure it in standalone mode. But guys, if you have lots of AP like hundreds of AP or thousands of AP, you cannot manage it manually, right? So you need a controller. Like in this scenario you can see I have 3 AP, AP1, AP2, AP3, and here I have one WLC controller. So this WLC controller is responsible to configure these AP and to manage these AP. Let's say you need to configure some security setting on these AP, so you will configure settings on WLC on this controller, and controller is going to push it to all APs, right? So all APs will get same setting configuration. Then I can use AP in breeze mode, as I told you, to connect two different network together, right? Again, in repeater mode means to repeat the wireless signal, I can use AP in mesh mode, means connecting multiple APs together to form a wireless network, right? For outdoor environment like park. Then we talked about real-time examples of a standalone mode. So if you are setting up a wireless network in your home or in a small office where you need few APs, 1, 2, 3 APs, so you can configure SSID, VLANs, these things manually, right? So network administrator can configure. So whenever a network administrator is configuring the AP, that is a standalone mode. If you are using a controller to manage the AP or to configure the AP, that is controller based mode. Then breeze mode, connecting two network together wirelessly. Repeater mode, to increase the network coverage. Mesh mode, connecting multiple APs together. In large outdoor event space, multiple APs are connected in mesh mode. They work together to cover the entire area, automatically routing traffic to ensure all people have reliable Wi-Fi access. The mode of APs determine its function and how it's interact with the network. It's about the configuring role of the AP, not a different physical hardware, right? So mode means not different type of hardware we have same hardware guys, same access point. Different mode means the configuration is different, right? Different modes allow the same AP to be flexible and meet various network needs. So using an AP in repeater mode and setting up a new AP to increase network coverage both have their own benefit and drawback. So which will, if someone will ask you which is the better way to connect AP to switch to increase the network coverage or use AP in repeater mode. So no guys, both have their own advantage, disadvantage, right? So if you want to increase the network coverage and running cable is impractical, then definitely you have to use AP in repeater mode to increase the coverage, right? And disadvantage can be reduced bandwidth. So here you can see benefit of using AP in repeater mode. No need for Ethernet cabling. You don't need to insert cable here. So installation is going to be easy, right? Setup is going to be easy. Effort is going to be less, right? Then quick and easy setup, as I told you. If you are not going to run cable, it will be easy to install it, right? To setting up a AP, repeater AP is simple. You configure it to connect the existing network and start repeating the signal. So once you will configure a AP in repeater mode, it will connect it with your existing network and it will start retransmitting the signal. So providing temporary coverage extension for an event. Let's say you have one event for 5 hours or for 2 hours. So for only 2 hours you want to extend the network. So you should use AP in repeater mode, right? Flexible and malleability guys, that means you can adjust the AP. As AP is not connected through wire, you can adjust the AP according to your requirement, according to your coverage area, right? So if you want to adjust the AP, like to shift the AP in a coverage area, let's say I want Wi-Fi signal in this area, right? So I will place AP over here. Definitely I will get weak signal in this area. So I can adjust it. I can move it to here in the center because I don't have any wire. Okay. Then disadvantage can be reduced bandwidth. As repeater AP typically have the available bandwidth because they have to receive and then retransmit the signal. So AP is not going to generate any signal in the repeater mode. So you will have reduced bandwidth. In home where streaming high definition video or online gaming required high bandwidth, using a repeater mode AP might slow down the network, right? So for the server connectivity guys, you will never use AP in repeater mode. Repeater using AP and repeater mode is just a temporary solution to extend the network coverage, right? Potential for increased interference. Yes, there is chance of interference as well, because you have not calculated the place for AP installment, for AP installation, right? So there is chance of interference as well. Then benefit of connecting AP to switch to set up a new AP. That can be new AP means again to configure the new AP. So configuring new AP means it will generate the signal. So you will have full bandwidth availability as new AP connected via Ethernet to the network does not share its bandwidth with other devices, right? So it is not going to share their bandwidth with other devices, providing full speed and performance. So you will get same bandwidth as switches providing. So in business environment where high speed internet is crucial for productivity, then you should use AP. You should set up new AP there, right? Better performance and reliability, scalability. So you can again increase the size. Again, you can use one AP to repeat the signal, right? So these are guys benefit of using AP in repeater mode or using a AP in new mode. Means you can say in the standalone mode or in the controller mode, means adding a new AP, using AP in repeater mode or adding a new AP. Okay, then guys again we have some important terms of networking, like once again, like SSID, service set identifier. You know, the SSID is nothing but name of your Wi-Fi network, right? Like in my office or in a building, there are multiple department, right? And for all department you need to create Wi-Fi network. So you can create SSID like office Wi-Fi for employee, you can create guest Wi-Fi for guest, you can create finance Wi-Fi for finance people, right? So for each department you can create different SSID, and then you can map it with different VLAN. So name of the wireless network, it's what you see when you look for Wi-Fi network on your device. So when the client machine will scan for Wi-Fi network, what name it will seen, that is SSID, right? So real time use case in the production network, the SSID is used to identify and connect to the correct wireless network, right? So employee will get connected with Wi-Fi, sorry, office Wi-Fi network only. So for example, in an office the SSID might be office Wi-Fi, so employees select this SSID to connect to their device, to the office network. Then guys, BSSID, basic service set identifier, the MAC address of AP's radio interface, right? So whenever a AP is transmitting signal, it need source address. So what is going to be source MAC address? That is BSSID. So BSSID means the MAC address of the interface of AP from which AP is going to transmit signal. Okay, so BSSID is the MAC address of access point or the wireless routers radio interface, or you can say access points radio interface. It uniquely identified as a specific AP within a wireless network. Now real time use case can be each AP in production network has a unique BSSID. It helps device to differentiate between different APs broadcasting the same SSID. For example, in large office with multiple APs named Wi-Fi, office Wi-Fi, and each AP will have a unique BSSID like this. This is the MAC address, 48 bits MAC address. So how a client will get to know that which AP is best for me, from which AP I am getting a strongest signal with the help of BSSID only. So let's suppose in the building guys, there are two floors. At each floor I have one AP, and both AP is transmitting same SSID, that is office Wi-Fi. Both AP is transmitting AP1, AP2, both AP is transmitting same SSID. Then how client is going to differentiate both AP? With the help of BSSID, right? Because BSSID is going to be unique. BSSID is going to be unique here. Then guys, we have another term that is called BSS, basic service set. Basic service set. So the basic service set is basic building block of a wireless network consisting of a single AP and its associated devices or client. So let's suppose I have few wireless devices and I need to connect these all devices to AP, to access point, right? Like this. And then your AP is connected with one switch, and then switch is connected with router is connected with maybe firewall, and then to internet, right? So one AP, here I have one AP who is connecting these all devices together. So you know, this is one BSS, basic service set. Basic service set. So consisting of a single AP and its associated devices or clients is BSS. So if someone will ask you what is BSS, so BSS is nothing but a wireless network with a single access point with their clients, right? So in the production network, a BSS represent a single AP and the devices connected to it. For example, in a warehouse, one AP might cover a specific area forming a BSS, right? So in packet tracer also you can see what is happening in this scenario. In this scenario, this AP is transmitting wireless signal, and this is how these devices are connected with the AP. So this is one BSS, one basic service set. One basic service set means one AP connected with their client devices, right, associated with number of client devices. Okay, in the same way, like here I have another AP as well, guys, and let's suppose this AP is also connected with the switch, right? And then this device, let me use another device here. This is television, like this. So now you can see I have two access point here. Okay, this device is connected with AP number 1, but suppose this is connected with AP number 2. So see guys, in this scenario I have two AP, right? This AP have these client and this AP have these client. So this is my one BSS, we can say BSS 1, and this is my BSS 2. So BSS means one AP associated with their clients. Getting my point? Hope it is clear. BSS, basic service set. Okay, all devices in that area connect to this AP, creating a localized network segment. The next term is BSA, basic service area. See, basic service set and basic service area, the difference is nothing but this is geographical area of BSS. Geographical area of a BSS is known as BSA, basic service area. So definition, the BSA is physical coverage area of a single BSS, right? Physical coverage area of a BSS. It represents the geographical area within which devices can connect to the AP, right? So to set up the wireless network, what you need to find? You need to find BSA, right? So BSA means area where you are going to place one AP, right? So let's say this is my BSA, basic service area, where I'm going to place one AP, and then I have lots of client, and these all clients are connected through this AP, right? So this is my BSS because I have one AP, which is associated with lots of end devices, and geographical area is known as BSA, right? So hope both term BSS and BSA is clear. So geographical area of BSS is known as BSA. Real time use case, you will see the why we have guys these term, right? When we will implement, when we will see the implementation of wireless network, it is going to help you a lot, right? So real time case can be in the production network. The BSA is the coverage zone of an AP. For example, in a hospital, each floor might have one AP. So the BSA means geographical area of each AP is the area of floor it cover, right? So actually BSA is going to tell you how many AP is required at each floor, how many AP is required at each floor, ensuring that all devices within that floor can connect to the Wi-Fi network, right? So with the help of BSA, you can find one AP is sufficient for one floor or not, or you need to install more AP, more than one. Okay, then office environment scenario. Now try to understand how we can configure the SSID or wireless network, how we can set up the wireless network. So let's suppose you need to set up a wireless network in office, in the office environment. So you will configure the SSID, guys, right? So your SSID is name of your wireless network, and it can be Wi-Fi, office Wi-Fi. So employees see this SSID on their device and connect to it. Then BSSID. The office has multiple floor. Each floor with AP broadcasting same SSID, that is office Wi-Fi, right? And each AP has unique BSSID. Okay, so AP on first floor have, let's suppose, this MAC address. So this is what BSSID of first floor AP. Then AP on second floor have this MAC address. So this is BSSID of AP on second floor. So devices connect to the nearest AP based on BSSID to ensure a strong signal. Okay, as I told you, how device will get to know which signal is the strongest signal. With the help of BSSID only, device is going to identify it, right? So SSID is clear, BSSID is clear. Now BSS. So AP has each AP and its connected devices form a BSS. Each AP and its connected devices form a BSS, basic service set. First floor AP's BSS include all devices connected to this BSSID, right? So let's suppose this is my AP at first floor, guys. AP, and this is AP at second floor, right? So MAC address of this AP is 45 in the last, and MAC address of this AP is 46 in the last. Getting my point? So whatever clients are there are connected with AP number 1. This is what BSS, and geographical area is BSA. And again, here we have some clients. This is what BSA, BSS 2, or BSA 2, BSA 1, BSA 2. Now if any client from BSA 1 will move to BSA 2 in this area on second floor, so on second floor, you know, your client will get a stronger signal from this MAC address, from this MAC address. In at first floor, on first floor, client will get a stronger signal with this MAC address. So this is how we are using BSSID. Fine. So BSS, each AP's head and its connected devices form a BSS. First floor AP's BSS include all devices connected to this MAC address, and second floor AP's BSS include all devices connected to this MAC address. Now BSA. The BSA of the first floor AP is the area it cover on first floor, and the BSA of second floor AP is the area it cover on the second floor. So employee can move within the BSA on their floor and stay connected. Employee can move within the BSA of their floor and stay connected. SSID help users identify and connect to the correct network. BSSID uniquely identify each AP within the network, allowing devices to connect to the nearest or strongest AP. BSS represent the AP and its connected devices, and BSA represent the physical area covered by an AP's signal. So in real time network, these components work together to provide seamless and reliable wireless connectivity across different areas and floors, ensuring that users remain connected as they move throughout the environment. Now, use of BSSID. So when a client device connect to a wireless network, it uses BSSID, which is the MAC address of access point, to ensure that it connects to the nearest or strongest AP. So now see how client will get connected with AP. Scanning for network. First step, client machine is going to scan wireless network. So client device continuously scans for available Wi-Fi network by sending out probe request message, right? So always keep in mind, now we are going to talk about two signal, guys. And first signal is probe signal. So client machine will send probe signal to AP, okay, and listening for beacon frame from AP, right? So these two signal, one is probe and one is beacon. So when client want to get connected with AP, client is going to send which signal? Probe signal, right? And AP will send beacon signal, beacon signal, right? So each AP broadcast is SSID, BSSID in this beacon frame, right? So at first floor AP is transmitting signal, right? And actually what it is beacon frame, and in the beacon frame it is transmitting what? SSID and BSSID. Getting my point, guys? Now, evaluating signal strength, how client will get to know which signal is good, best. So client device measure the signal strength with the help of RSSI, received signal strength indicator. Received signal strength indicator, again it is a tool, right? Features on the client machine. So client device measure the signal strength with the help of RSSI of the become frame it received from different AP, right? So as I told you, I have two AP, one at first floor and one at second floor, AP1, AP2. Guys, there is one client. This client is getting signal of both AP. Both are sending beacon signal, right? In the beacon signal, both are sending both their SSID and BSSID, right? And with the help of BSSID, this client machine will find which signal is strong, and what tool this client machine will use to find the strongest signal or SSI, received signal strength indicator, right? And a stronger signal typically indicate that AP is closer, right? So if I am getting a strong signal from AP2, that means I am nearest to AP number 2. If I am getting a strong signal with different MAC address, means with the MAC address of AP1, that means I am closer to AP number 1. Now, selecting the best AP, the client compare the signal strength of the received beacon frame. It select the AP within the strongest with the strongest signal, which is likely the nearest and least or least obstructed AP. Let's suppose there is one wall between AP. Even you are closer, but your signal is weak because of that wall. Okay. So how AP is going to select, how client machine is going to select AP on the basis of beacon signal. In the beacon signal, AP is transmitting SSID and BSSID. BSSID is unique, SSID is same. So with the help of BSSID, client machine is going to identify which signal is stronger. So if client machine is getting a stronger signal from AP number 2, that means I am nearest to or closest to AP number 2. Now connecting the two AP. Now the third step. First step, sending probe signal, receiving beacon signal. Third step, connecting to the AP. So client send an association request, right? Client machine will send one association request message to the selected AP. Selected AP means, let's suppose client machine is getting a strongest signal from AP number 1, AP1, AP2. Here is the client. Client is getting beacon signal from both AP, but it is getting a stronger signal from AP number 1. Suppose MAC address of AP1 is A, MAC address of this AP is B. So if this client machine PC is getting a stronger signal with this MAC address, A MAC address with A BSSID, so client machine will send association message to AP number 1, not AP number 2. Okay. So client machine will send association request message to selected AP, right? Using the AP's BSSID. So destination MAC address in the association request message is going to be MAC address of AP1, right? Destination MAC will be the MAC address of AP1 because client machine have already MAC address of both AP1 and AP2. But as it is receiving a strongest signal from AP number 1, it will send association request to AP number 1, and then AP is going to send association request response message. So next step is the AP respond with an association response message, completing the connection process, right? And after that, client will get connected with your AP. So real-time scenario, AP deployment. An office has multiple APs deployed on different floors or area. Each AP broad each AP broadcasts the same SSID, that is office Wi-Fi, but has unique BSSID, that is MAC address. For the first floor AP, let's suppose this is the MAC address. For the second floor AP, MAC address is different. Then guys, client device scanning. So an employee with laptop enter in the office, the laptop scan for available network and detects multiple SSID, including this name, office Wi-Fi, from various AP. But the difference is each signal will have unique BSSID MAC address. So signal strength. Now your client machine is going to find the signal strength. So laptop receive beacon frame from the first AP, from the first floor AP with BSSID this, and the second floor AP with BSSID this. The signal strength from the first AP is stronger. Let's suppose this one compared to the second AP. Here we have minus 70. So as client machine is getting a stronger signal from AP number 1, AP select AP selection. Next step is going to be AP selection. So client machine is going to select AP number 1. If client is on first floor, again when client will move to second floor, it is receiving signal from both AP. Again client machine is going to compare it. And guys, this time as client machine is nearest to AP number 2 because client is at second floor. So client machine will get a stronger signal from AP number 2. So it will select AP number 2. So whatever client are there at first floor will select AP number 1, and all the employees at second floor will select AP number 2. So AP selection. So based on the stronger signal strength, the laptop decide to connect first AP with this BSSID. Now connection process. The laptop send an association request to the first AP using this BSSID. The first floor AP responds with association response message, and laptop is now connected to nearest AP with best signal. Right. So hope this is clear how device will get connected with your AP. Now factor influencing AP selections. Right. So signal strength. This is first point, signal strength. It totally depends on signal strength. If a client machine is getting a strong signal from AP number 2, then definitely it will select AP number 2. The primary factor as a stronger signal usually indicate fewer obstruction. Roaming algorithm. Advanced clients and networks use roaming algorithm to decide the best AP based on signal strength, network load, and other factor. It is not like if you are nearest to the AP, then your machine will get connected with that AP, means AP number. If you are at first floor, so this is not sure that every time you will get connected with first floor AP, because let's suppose there are lots of load, guys, lots of devices are already connected with AP number 2 and AP number 1, and AP2 is also transmitting signal at first floor. So there is chance that your machine can get connected with AP number 2, right? So it depends on various factors. First is signal strength, then you have load or other factors are there. Then interference and noise. APs in less noisy environment may be preferred. So if there is less interference, less noise, then definitely your client machine will prefer to that AP. Okay. Now roaming process. How a client machine moves from one AP to another AP. Okay. So we will discuss roaming process in next class, guys. Okay. This is all for today. Hope this video was helpful for you. If you have learned from this video, please hit on like button, guys. And if you want more videos, if this wireless playlist is helping you, then please type yes in the comment section. Once you will type yes in the comment section, I will get to know yes, these video are helpful for you. It will motivate me. If you will type yes in the comment section, guys, it will motivate me to make more videos. We'll try to upload one video every day in this playlist, and after that, after this playlist, I will plan any another playlist. Actually, I am planning for network designing, so we'll try to create one playlist for network designing. Okay, so that's all for today. Let's meet in next video. Till then, stay safe. Bye bye, guys.